very good. Thank you. So listen carefully. Yes, this is the question. Derive an expression for the capacitance of a capacitor for 5 marks. First of all, let us think about what is a capacitor. A capacitor which is having two plates separated by a small distance. Is it right? There are two plates, one plate, another plate like this. The two plates are separated by a small gap. The gap may be filled with air medium or may be filled with some dielectric medium. I said some dielectric medium means it is said to be an insulator. Maybe it is paper, maybe it is the sand material, or maybe it is said to be the granite powder. Okay, or it may be the paper. I said already, I think. Okay, maybe you can put glass also. Usually we are putting either it is maybe honey wax or maybe candle wax that we can put between the two plates. Honey wax, candle wax, like that we are putting. That is also a good insulator. Right? Understood? Like that, different types of capacitors which are available. Electrolytic capacitor, paper capacitor, like that. So many varieties of capacitors which are available in the market. Of a small size to a huge size which is available. Now let us derive an expression for what? Capacitor. Okay. It carries 5 marks. There are two plates. Okay. They are similar plates. The two plates, they have been kept parallel to each other. Each plate is having an area of is equal to capital A, and this plate is also having an area is equal to capital A. And the one plate to another plate here, the distance of separation is equal to d. And the first plate is connected to the external battery, which is positive. The second plate is connected to the negative end of the same battery. Therefore, between this plate to this plate here, we are applying a potential difference of V volts. As you are applied a potential difference of V volts here, between the two plates, there is a potential difference is equal to V volts. And whenever if you are connecting to the positive end here, this plate is containing the positive charges and the second plate is containing the negative charges, because the second plate is connected to the negative end of the battery. And between positive to negative here, let us assume, don't forget, let us assume actually in the higher classes, between one plate to another plate, the electric field, whatever it is present here now, at the edges which is not uniform, but at the center there is uniform electric field is there. At your level we can say that, let us imagine, let us consider between one plate to another plate, there is a uniform electric field intensity. That uniform electric field intensity, already we have derived that equation. What is that? If a single plate is said to be existing here, if I am choosing a single plate, which is a charged one here, an infinite plate which is said to be already charged, nearby that I will going to consider a point P here now. At that point P, using the Gauss theorem that we have derived, electric field intensity is equal to sigma divided by 2 epsilon naught, where sigma is surface density of charge for one plate here. So let us use that idea here. So if I am choosing one plate here, here E is equal to sigma divided by 2 epsilon naught. Due to this one, along the same direction, there is electric field intensity is equal to sigma by 2 epsilon naught. For one conductor, this one. For another conductor, this one. Because I am adding these two, since these two, whatever the intensities are acting in the same direction, the total electric field intensity is follow this. But above this one and below this one, okay, one field intensity is acting in one direction, the other field intensity is acting in opposite direction. The net intensity is equal to 0. So here actually electric field is equal to how much? 0. Here also electric field intensity is equal to 0. But between one plate to another plate, there is a gap is there now. There is an electric field intensity. That electric field intensity is equal to this. Follow this? No. What is that sigma? It may be defined as charges divided by area. Charge divided by area. Use that concept here. Sigma is equal to charge divided by area. Charge is equal to sigma into D. But already we are aware of that. Okay, V is equal to E into D. Or I can say E is equal to D. electric field intensity, one of the SI unit is Newton per Coulomb, another unit is volt per meter because of this volts per meter. This is potential difference divided by the distance of separation. This SI unit is volt, this SI unit is meter. Therefore, volt divided by meter, volt per meter. Therefore, E is equal to V by D or V is equal to cross multiplication E into D. But already we know the E value, sigma by epsilon naught into D. We know one more equation, that is a definition for capacitance of a capacitor. The capacitance of a capacitor may be defined as ratio between the number of charges to the potential difference. C is equal to Q by V, and hence C is equal to Q value I will substitute here, V value I will substitute here, okay, sigma A, and the denominator if you are taken to the numerator is going to get reversed, okay, reciprocal that I have written. Sigma get cancelled, you are going to have epsilon naught A divided by D. Let us imagine between the two plates air medium is said to be existing, therefore I have written air medium. The SI unit of this capacitance is so many farads. Clear? Let us consider between the two plates here it has been filled with some dielectric medium. Maybe it is granite powder, or maybe it is sawdust material, or it may be the glass, or it may be something else, paper. It's a good insulator. Instead of air medium, something else we are going to put which is said to be a good insulator. That can be written as dielectric medium, represented by the dielectric constant K, or it may be represented by relative permittivity epsilon. This is a old terminology, this is new terminology, nothing else. Okay, if we are introducing that one, then this equation becomes epsilon naught into one more constant epsilon naught multiplied by A divided by D, so many farads. So meaning, if you are using the air medium, capacitance is less. If you are using a dielectric medium, capacitance is going to get increased. How many times? Epsilon r times it is going to get increased. If you are using epsilon r is equal to 2 times it is increased compared to this. If this is equal to 1.5 times this value it is more than this. I hope you understood. One more question, that is, if you are introducing a dielectric medium, what will happen to the capacitance of a capacitor? Increases. If you are removing the insulating material and if you are putting the air medium, what will happen to the capacitance? Decreases. This is a one more question that we can find. Coming to the other idea here. We are asking 2 marks question without derivation also. Write an expression for the capacitance of a parallel plate capacitor. Directly I am writing this equation and I am writing this equation here. But once if you are writing an equation here, you are supposed to explain whatever the factors which are present here. Epsilon naught is called by the name absolute permittivity for the free space. The value of that one is 8.854 10 to the power of minus 12 farad per meter. Epsilon r is called by the name the relative permittivity. A is the area of each plate. Small d is the distance between the two plates. If you are writing that much, you will get 2 marks. Next idea is explain on the factors by which the capacitance of the capacitor depending upon. What factors, how it is depending upon, you are supposed to explain. The capacitance of a capacitor is directly proportional to this epsilon r. Epsilon r value is more and more and more, capacitance value is also more. That's why I said here, as you are introducing a dielectric medium, capacitance is going to get increased. That is the meaning. As the area of each plate is increases, capacitor size is also increases. As the size is increases, because area is also, each plate area increases, then the charges it can store more and more here, therefore capacitance is also increases. Second, that is the third point. What is that? The distance between the two plates is go on decreasing like this, up to a limit. Capacitance is go on, increases. Distance decreases, capacitance is go on, increases. One more question now, again, for your maybe the entrance examination or something. Between the two plates, which is said to be a capacitor, already charged. Just to answer it, this is already charged, this is also already charged. Just like here, this is charged, this is charged. I will remove this. Battery I will remove, already discharged. This is also charged. exactly between this plate and this plate here, I will going to introduce here thickness is equal to small d, like that the thickness of the material is equal to small d. An iron slab I will going to introduce. Which slab? Iron slab I will going to introduce here. What will happen to the charges? Answer. What will happen to the capacitor? Have understood the question? The question is between the charged two plates. I will remove this. Once it is charged, I will remove the battery. So here exactly this thickness is equal to small d. I will going to introduce one iron slab. What will happen to the capacitance of the capacitor? Answer. Capacitor which loses its identification means no longer it is acting as a capacitor. It loses its capacitance idea, because if you are introducing an iron rod here, iron is a conductor, but this is no problem. But iron is a, if you are introducing a conductor here, charges are flowing from here to here. How many charges are stored then? Zero. If the charges are flowing here, how many charges are there? Very simple. For what purpose we are using a bank? Money bank. To store the bank. If you are storing the money, there it is. Every day we are going and storing the money, depositing the money, and every day if they are going to say that your money is zero, your money balance is zero. If the bank officials say that, are you going to store your money? Are you going to deposit your money? Similarly here also. As you are go on storing here, and if you are putting a iron rod or something else of the thickness is equal to d here, charges whatever you have given, it is simply flowing. Instead of storing, what will happen? It is go on conducting. If it is go on conducting, number of charges stored is equal to 0. Therefore, no longer it is acting as a capacitor. One of the entrance examination, they ask this question. Okay? The other entrance examination questions here now using this or this, no problem. Okay, what is that? If area of each plate is doubled, what happened to the capacitance? Answer? Double. Okay, the distance between the two plates is decreases by half. Decreases by half. Capacitance value? How many times? 2 times. If it is decreased by half, capacitance value increased by 2 times. Reverse. That is the reverse. What is that? Inverse proportionality. Shall I write it? No, sir. Secondly, third idea. If area of each plate is increases by 2 times, distance is decreased by half, both together, then capacitance? Again I will repeat. Capital A is increases by 2 times, small d is decreased by half. 4 times. Capacitance increases by 4 times. Like this, thousands together questions we can frame. One more question. Capital A is increased by 2 times. Epsilon r, it is increased by 2 times. That value is equal to 2. And small d, it has been decreased by half. What is the new capacitance value? 2 into 2 into 2. How much? 8. Like this I can construct more than 1000 questions about this one only. But you people, you had to analyze about this concept, you had to analyze and you had to go on calculate, and you are supposed to say the correct answers. Understood? Okay. So within this, any doubt is there, you can ask.